Hi all, good afternoon. I hope you are having a great day so far. Welcome to session 4 of Well Intervention, hosted by Arab Oil and Gas Academy, founded by Vitro of Merit College and SPE Egypt. My name is Usul Hashimi and I'll be your moderator for this webinar. I'm a petroleum engineer and doing my master's degree at University of Essex. I'm pleased to reintroduce Engineer Ahmed Elzeftawi. Engineer Ahmed has 34 years of experience in the oil industry covering the Middle East in coal tubing, nitrogen service, wireline well testing, completion and downhole tools. Engineer Ahmed got his bachelor degree in mechanical engineering from Cairo University in 1983, has work experience in coal tubing, completion, wireline, well intervention covering the following as an operator, supervisor, consultant, instructor, and manager in more than 17 different countries. And now, I'd like to mention that today's webinar will be, of course, available after the live session on by Vitro YouTube channel. And if you have any question for our speaker, please feel free to put it in Q&A button tab at the bottom. Okay, and please share the webinar of your social the webinar on your social media network and invite others to join. So now let's welcome Engineer Ahmed Ziftawi. Sir Ahmed, the mic is yours.
Thanks, Rosal, and good morning and good afternoon, everyone. Hope you will enjoy this short session on completion. This is actually our second and last one, as the next session will be coal tubing. So today, our topic today will be Packers, which is an isolation device, if you remember from last session. We'll talk about the anti-erosion devices, wireline entry guide, tubing hanger. And by finishing these topics, we will finish the completion part, which is below ground. Then we will talk about the rest of completion, which is above ground, which is Wellhead and Christmas tree. So let's start with the isolation device. And the word isolation means Packer. Packer is there for isolation. What's a Packer? We say it's a tool. When set, it seals the annular area between two strings of pipe, mainly completion and the casing. And as you see, it's the blue part here that isolated tubing, which is the yellow color, and the casing, which is the gray color. This is the main reason for the Packer. So actually, if you see here in this drawing, where we have fluid coming from the formation, entering our well, what prevents the oil, gas, and water from entering the annulus, this area? It is the Packer. And actually, it helps us also, since we drill our well, we run our completion, and we start producing from this well. And let's assume that this well is producing 500 barrels a day. After a period of time, you will notice that the production rate of this well start to decline, to decrease. And instead of being 500, it might be 450, 300, whatever. Why? Why this decrease? Why this declination of production? Many, many reasons. One of the reasons that the formation start having a lot of scales and sediments, paraffins, wax, preventing the oil to escape between the grains, goes all the way to our well and then for the production. To solve this problem, one of the solutions is to pump, to do stimulation job, pump acid. So this acid we pump through production tubing. It goes from the production tubing, goes all the way entering the formation to clean these scales, debris, wax, paraffins inside. If we don't have a Packer actually in this well, so this treatment that you are doing, instead of going into the formation, it will be easier for this to go through the annulus, filling the annulus here, damaging our casing. So the Packer is preventing this treatment fluid from entering the annulus, damaging our casing. So the function of the Packer is to isolate. Keep this in mind, the word isolate. Where we put the Packer? Normally we put it on top of adequate space on top of the perforations. On top of the perforations. The common type of Packers we have in the industry is either permanent or retriever. We will talk about these two different types, the permanent Packer and the retrievable Packer. What you see in front of you now is the permanent and the retrievable one. And you will notice that they are similar. Any Packer consists of three main elements. Body, which you see it here in red color, and the sealing element, which is what you see here in black color, and slips that bites in the casing and keep the Packer in place, which you see it here in yellow color. So what you see here in the drawing, this is the Packer in yellow. What you see below, the Packer is, if you remember from previous session, we said this is the tailpipe, or this is the bottom completion. Remember we said that the Packer is the line. Anything below the Packer, we call it bottom completion. Anything on top of the Packer, we call it top completion. The bottom completion, or the tailpipe, actually consists of a couple of joints, a perforated joint, wire line entry guide, a couple of landing nipple. This tailpipe is hanged by the Packer, where the top completion is hanged by the tubing hanger. So the tubing hanger, it hangs top completion only, where the bottom completion is hanged by the Packer. So if I ask you a question now, why Packer? What's the purpose of the Packer? And one of the answers you select is to hang a bottom completion. You take 0 in this question, because this is not the purpose of the Packer. The purpose for the Packer is to isolate. Hanging the tailpipe is a favor. It is not in her job description to do that. It's exactly like the example I gave you in the last session. If you remember that I'm going to the supermarket to buy a bottle of milk for me, but then Dr. Ahmed Al-Garhi said, Ahmed, on the way back, would you please get me a packet of cigarettes? If you guys ask me, Ahmed, where are you going? I'm not going to buy a packet of cigarettes, Dr. Ahmed. I am going to buy milk for me. Getting the cigarettes for Dr. Ahmed, this is a favor, not in my job description. So remember, El Packer is to isolate, nothing else. Whether I'm going to use the permanent Packer or a retrievable Packer, and how to run this and how to run that, if we select the permanent Packer, if our design is to use permanent Packer, then we will run a permanent Packer independently, meaning that we will run a permanent Packer before we run a completion. We have two methods to run a permanent Packer. Either to run it with the string, with the drill pipe. So we connect the Packer and then we start running drill pipe, putting more drill pipe till we reach the desired depth. of setting the Packer. When we reach the desired depths, now we are ready to settle Packer. By this application, we will settle Packer hydraulically, where we put a plug in the tailpipe below the Packer. If you see here, we agree that the Packer is the yellow color, right? This is the Packer. And then below the Packer, we have here landing nipple. So we will set it in this landing nipple. We will set the plug. And then we will apply pressure from above through the production tubing, above the plug, till we reach the desired depths, the desired pressure that will shear the pins, which is setting shear pins inside the Packer. Once these shear pins is broken due to this pressure, the slips, which is in yellow color, you see it, will expand and bite on the casing to set the Packer in place. And then these packing elements, the rubber element in red and in black color, you see it, it will expand due to temperature and make the seal against the casing. By doing this, we set the Packer hydraulically. We can settle Packer actually electrically if our selection is different. So if we're going to run it not through the drill pipe, by the drill pipe, but we will run it with E-line. E-lines mean electric line. So we run it with the electric line, go deep into the well to the desired depth. Then from the surface, we push the bottom. Actually push two bottoms, because this bottom we push, we will have an explosive in this Packer, we'll charge it, and then this will break the shear pins, slips will bite on the casing, rubber element will inflate due to temperature and seal against the ID of the casing. Packer is set. In this case, we set it electrically. And actually, I said press one button, but actually press two buttons, because if it is one button, you might press it by mistake and set the Packer in somewhere else. But by pressing two buttons away from each other at the same time, that you need to do that. So a permanent Packer, we can run it with the drill pipe. In this case, we're going to set it hydraulically by applying pressure inside the tube on top of the plug that we put in the tailpipe, in the tubing landing nipple below the Packer. In this case, we set it hydraulically. Or we can run it electrically by using electric line, running the Packer to the desired depth, and then with the explosive charges, we break the setting shear pins, and then we set it electrically. Either you set it electrically or hydraulically, what I need you to know that by setting the permanent Packer, you cannot retrieve it again. That's why it's permanent. It became an integral part of the casing. The only way to retrieve this Packer is by milling. You have a drill mill, you drill or you mill, drill or mill. Is there a difference between drilling and milling? Is there a difference between a drill mill and the drill bit? Yes, there is. The drilling mill, we use it to drill metal. But a drill bit, we use it to drill cement or concrete, or even rocks here. So we use a drill mill in our case because we are going to drill metal. So we drill it, we mill it actually all the way to the rubber element, and sometimes we have to mill even the rubber element if the Packer has been set for a long time. Then we suffer from milling the rubber element as well. But this is, as I said, permanent Packer. Once you set it, it became an integral part of the casing, and the only way to retrieve it is by milling. Once you set the permanent Packer, now you run the completion. Packer, if this is the Packer, see, this is the Packer. It's hollow from inside, of course, as you see. And then I'm running the completion. When I run the completion, this last part of the completion, we call it tubing seal assembly, which is a piece of pipe. It has a lot of rubber outside, packing elements, too many sets of rubber elements, that when I run the completion, this tubing seal assembly, it goes inside the bore of the Packer. This moment we call it sting in. The sting in is the moment that the tubing seal assembly, which is part of the completion, it goes inside the Packer. Once it goes, this outside sealing elements, it seals within the ID of the Packer. And then we have the completion as one part. This tubing seal assembly, it will goes and stop at the top, or will go to the middle of the Packer, or it will go all the way in. I cannot answer this question as I don't have enough data. If you need me to answer this question, then I have to tell you, okay, this well is production or injection. Production means this well is made so you can produce oil from. Or injection well that you have to inject water inside this formation. Do we do that? Yes, we have injection well. We drill it outside the reservoir so we can inject water, so the water will push the oil to goes out. This is one of the artificial lift methods, but this is not our topics today. So back to the permanent. This well is production. Okay. Then I will, when I run the tubing seal assembly, I will go run till it goes to the middle here. This is the middle. Why? Because during production, completion is metal, so it will expand due to temperature. So when it will expand, there will be a space below to go through. But if this well is injection, so when I run the tubing seal assembly, I will go all the way in to the Packer. Why? Because this is injector well. When you inject water, the tubing will be cooled, so it will shrink. So if the tubing seal assembly on top here only, if it shrink, it will pop out. Pop out means it will go outside the Packer. That's why in injection wells, the tubing seal assembly, when we run it all the way in. While in production wells, the tubing seal assembly, we run it to the middle. So we have a space below for the expansion due to temperature. This is about permanent Packer. But if our selection is to run retrievable Packer, then we run it with the completion. It is part of the completion. It is fixed to the completion. So we run it all the way to the desired depths. Now we need to set it. You have two ways to set it. Either hydraulically, exactly like the permanent Packer, where we run a plug and we set this plug in the landing nipple below the Packer, and then we apply pressure from top, from the completion tubing on top of this plug. We increase the pressure till it reaches the desired pressure to shear the pins, to shear the setting pins of this type of Packer. Once the pins is sheared, same situation will happen. The slips will bite on the casing. The rubber element will inflate due to temperature and make the seal against the casing. Now the packer is set. We set it hydraulically in this case. Or the other way is to set it mechanically. Some type of packers, when you reach the depths, the designer tells you you have to rotate it quarter turn to the left. So if the packer at 12,000 feet depth and you need to rotate it quarter turn to the left, you have to rotate the whole completion. And to make a quarter turn left at a depth of 12 or 13,000 feet, you might at the surface need to make 12 or 13 complete turns just to give you a quarter turn at that deep depth. It's not recommended, actually. We prefer always the hydraulic set packer, where it's easier for setting. This type of packer, once we set it, it is the retrievable type. Retrievable type, that means I can retrieve it. How we retrieve this type of packers? You apply tension. You pull it. You put maybe 60,000, 70,000 pounds over pull, depends on the design. And once you do that, the packer is unset. And you can pull it all the way up. And you can set it again, but to set it again in the same way, you have to take it all the way out, because you have to make a complete redress for this packer. Once you make the redress, you can run it again. Now I have a question for you guys. Let us assume that you run a packer, retrievable type, and you run all the way because you need to set it at 14,000 feet. You went to 14,000 feet, you try to set the packer, you spend there half an hour, 40 minutes, and you are not able to set the packer. So you decided to pull out of the hole to see what's the problem, why you cannot set the packer. So now the packer is at 14,000 feet. It has been there for 40 minutes, 45 minutes. You decided to pull out. While pulling out of the hole, what considerations you should take? Just pull out of the hole? Oh, remember, this packer has been in a depth of 14,000 feet for almost 45 minutes. So the rubber element at the packer, due to temperature, it is inflated. So while pulling out of the hole, you might not have enough clearance between the OD of the rubber element and the ID of the casing. So while pulling out of the hole, you are swabbing. It's like injection. This affects badly your formation. So while pulling out of the hole, you should restrict your speed to prevent this swabbing effect you might create. And your eyes should be always on the weight indicator. The weight indicator that tells you the weight you are carrying. Because if during the pulling out of the hole, you notice that the weight indicator is getting up, you have to stop. You know these indications on this increase of weight. This tells you that while pulling out of the hole, you don't have this enough clearance between the ID of the casing and OD of the packing element of the packer. So the rubber element is stucking. So what you should do is stop and wait for an hour or so, allowing the element to deflate before you start pulling out of the hole. This is one of the considerations you have to take into account. Am I going to run retrievable packer or permanent packer? It depends on the application. Normally we say that the permanent packer it is designed to withstand high differential pressure, high differential temperatures. So we mainly run it in gas wells. The retrievable Packer, we run it in wells that not high pressure, not high temperature, and wells that we know that we will change the completion frequently, like wells with high concentration of H2S or CO2, that it will eat this completion that we have to change it regularly. That's the difference between permanent and irretrievable. We have some other types, but this is not the course to talk about it actually in well intervention. As you see, permanent Packer, it resists high pressure, resists high temperature. As we said, it's an integral part of the casing once it's set and retrieved by milling only. We can set it hydraulically or electrically. Shear, don't care about number 4 and number 5. It's not for you guys, yani. But go through them quickly, yani. In permanent Packer, once you set it with running tools. When you set it electrically, then you need to get release from the Packer. But this setting tools actually, it has a safety device called shear studs. This shear studs will not allow you to release from the Packer unless the Packer is fully set. Because actually, if you release from the Packer while the Packer is not set yet, what happens? The Packer will fall on the open hole. And the second thing regarding an electric Packer setting is the tailpipe. We said that when we run a Packer regarding permanent or retrievable, the Packer we have below the Packer, this tailpipe, this couple of joints we said. Could this couple of joints be 20 joints, 30 joints? Can the Packer withstand this weight? Of course not. So the weight below the Packer of the tailpipe should be adequate to the carrying capability of the Packer itself. Otherwise, if it is too much, you cannot set the Packer properly because of this excess weight you have. And this is the retrievable Packer. We said we run it with the completion. We can set hydraulically by applying pressure inside the tubing, or we can set it mechanically by rotation because it has G-slots here. Retrieved by overpull. We said 60,000, 70,000. We shear a releasing pin because this type of Packer actually, retrievable Packer has two types of shear pins. The one we use to set the Packer and the one to use to release the Packer. Flow coupling and blast joint, which is the part number 4, which is the anti-erosion device. We said the anti-erosion device, we have 2 items. We have flow coupling and we have a blast joint. What you're going to see now, this is the flow coupling. And what you see beside it is the blast joint. But before we go to the blast joint, this is the flow coupling. What's the flow coupling? The flow coupling actually is a piece of pipe. The only advantage it has is heavy wall thickness. Heavy wall thickness. Why we use this kind of short pipe, heavy wall thickness? We put it below and above any restriction we have in the completion tubing, which is mainly accessories. Any accessories you run with the completion, whatever it is, SSD, SPM, landing nipples, whatever, it has a smaller ID than the ID of the completion, like what you see here. What's in brown color, this is the completion production tubing, this is the tubing. What you see in yellow above it here, this is the flow coupling, which is, it has the same ID of the tubing, but heavy wall thickness, the OD is larger. And what you see here, this is the accessories you have, which is smaller in ID than production. What's the problem we have now? Let's assume that you are driving in a highway and you have 4 lanes. And in these 4 lanes, you have 4 cars, each car in 1 lane. No problem. But what we have ahead of us is an accident, a car accident. So lane number 1 and lane number 2 are occupied with this accident. So when these 4 cars reach the accident, now we have 4 cars would like to go in 2 lanes only. Which one of these 4 will go in 2 lanes? So over there, in my country at least, there will be a fight. Who goes first? Who put his nose first? In some other countries, it's a problem because each one will say, please go ahead first, please go ahead first. No, none of them will go. Anyhow, these 4 cars will go into 2 lanes, so there will be a kind of a fight there. This is the same thing that happened with the flow. The flow, while going out in this production tubing, it goes in laminar flow. Laminar flow, that means they don't fight each other. But then they reach the restriction, smaller ID. When they reach the restriction, the fluid will start to fight. Who goes first? So the fluid will not work as a laminar flow. It will be a turbulent flow. Turbulent flow, it goes in waves. These waves, actually, it eats the ID of the tubing. It erodes the ID of the tubing. Then they go inside the accessory, whatever the accessory is. The accessory has 2 lanes, so we have 2 cars in 2 lanes, no problem. When they go out of the accessory, the ID of the accessory, they go back to the original idea of the production tubing. In high pressure wells, they raise their speed. So also above the accessory will be a turbulent flow that eats, it erodes the ID of the completion tubing. And here, since you have a copy of this presentation, you'll see US here means upstream, DS means downstream, and FCD here means flow control device. Flow control device, which is mainly the accessories and the valves. So if this erosion happen, internal erosion happen, it will eat the pipe, then each 1 year, 2 years, I have to change the completion. So to eliminate that, we use this flow coupling, which is heavy wall thickness. So it will remain longer, it will last longer, it will resist this kind of hammering or eating, erosion. So flow coupling is to resist the internal erosion due to the flow characteristic while passing through a restriction. And the other type is the blast joint, which we discussed it in our previous session. This is the blast joint, which is the same. It is a short pipe, heavy wall thickness. But this blast joint, we put it in front of the formation. You see it here in this drawing in yellow color. It is in front of the perforation exactly, because while producing, oil is coming in a very high speed, mainly with sand, so it hits the OD of the pipe, makes sand blasting. So in a very short time, this tube will have a lot of holes. If this happens, we have to stop production, bring a workover rig, pull the completion, change the damaged part, run again. It's a headache, a lot of money, waste of time. So instead, we put this piece of pipe, which is heavy wall thickness, in front of the perforation. Heavy wall thickness, it has the same idea of the tubing, but longer, but bigger OD. So it will last longer Instead of 2-3 years, it might be 5-6 years. And sometimes we use different material like tungsten carbide or ceramics. But this is why we use blast joint. Blast joint is mainly for to prevent the outside erosion, while the flow coupling is for internal erosion. Wireline entry guide. The wireline entry guide is the last bottom piece in the completion. Because if the end of the completion it's cut like that, and if you run in the hole with your tools, bottom hole assembly, and pass the production tubing and you work on the open hole, if you need to go back, you might stuck at this end and cannot pass, go inside. So you have to have a certain profile to make this easy back access easier. That's why we have the wireline entry guide. And actually, I don't like the name. The reason they call it wireline entry guide, I believe, because they invented wireline before in coil tubing. But if they invented coil tubing before, by now its name will be coil tubing entry guide. Because the slick line has been invented back in 1932, while coil tubing is invented in 30 years after. It was in 1962, the first prototype we have. Anyhow, it's actually an entry guide to any tools. You pass through L tubing and enter an open hole. You need to do a certain job, and then you need to go back. Two types we have of wire entry guide. You see it here. We have the Miller shoe type and the bill. The bill because it has the bill shape, bill type. And here, what you see is an actual picture of wireline entry guide. And you see here, this is the one that is upside down now. When you go inside now, the tubing, you see here, it has 45 degrees to make the slope. It has a slope of 45 degrees, so it makes easy for the tools to go back inside the tube. So this is the bottom most tubing accessories, and we said we use it to provide easy access for the bottom hole assembly going back into the tubing. Tubing hanger. From its name, tubing hanger, it is to hang a tubing. And I think after the session, Dr. Ahmed will distribute exercises to you guys. Do not let the question fools you. I repeat, do not let the questions fools you. Meaning, I'll give you a question, and then you to take 3 good answers out of the following about tubing hanger. And one of the statements that you can select, some of you select, it says that it hangs tubing and the top of casing. And you take correct. If you do that, I should kill you. That's a totally wrong statement. Come on, Ahmed, it says that it hangs the tubing. Yes, but please continue. And the top of casing? The tubing hanger. Hang the top of casing? No. The casing has its own casing hangers. Whatever it is, top casing, bottom casing, middle casing, each one of them has its own casing hanger. Please remember, a tubing hanger is to hang a tubing, and to be more precise, it is to hang a top of completion only. Because what hangs the bottom completion is something else, which is the packer. So a tubing hanger is to hang a top completion only, please. And here what you see with these black lines, these are seals. These seals is to prevent the leakage from a tubing to annulus or an annulus to tubing. So you make me crazy when I asked you to select good answer about tubing hanger, good statement about tubing hanger, and then one of the statements say it allows communication, and then you take it. Regardless, it allows communication from where to where or whatever. It does not allow communication. Actually, tubing hanger does the opposite. It prevents the communication. But Ahmed, come on. Read the statement to the end. However, I will read the statement to the end, but before I read the statement to the end, the tubing hanger, we said it is number one, to hang the top completion. Number two is to seal between a tubing annulus tubing to prevent the leak from both. And what you see in here in this tubing, you see this groove? This groove actually is to connect or to let the tube, the stainless steel tube 1/4 inch control line, to go through all the way down to the landing nipple or to the downhole city valve itself, which is maybe 200-300 feet away. So the statements that you select, guys, Ahmed, yes, it is to allow the control line to be going through to connect to the. So then people who select this answer, I said, so the tubing hanger, we manufacture it. So, and fix it in our well, just to allow a control line to pass through it, going all the way down to the landing nipple of the downhole city valve. If this is the case, then I don't need it. Simply, I don't need it. Because without it, the control line will go inside the well easier. It has no restriction to go. So come on, you cannot select this. The tubing hanger does not allow communication. It prevents actual communication. So tubing hanger is to hang a top completion. It has seals to seal between tubing annulus or annulus tubing. And actually it has a profile inside it to put a plug, we call it BPV, back pressure valve. This back pressure valve, we use it as a barrier, preventing oil escaping to the surface in emergency. Like if we need to change a Christmas tree, for example. If you have a problem in your Christmas tree and you need to change it, you have two ways to go. Number one, kill the well so you can change your Christmas tree. But if you remember back 2-3 weeks ago, we said that killing the well is your last resource. You have many solutions before you do that, because killing the well is the solution that will cost you a lot of money. Not in killing, actually, but as I said, in reinstated production from that well. So, as I said, to change this damaged Christmas tree, either to kill the well, which is something we said this is our last resort, or creating 3 barriers below the Christmas tree. Then the Christmas tree is extra, now you can take it. What these 3 barriers we normally take or use, we run a plug, we put it at the tailpipe and make inflow test to be sure it is working. Number 2, you can fill the tubing on top of the plug with fluid, with liquid that create hydrostatic head greater than formation pressure within 200 to 300 psi. This will be your secondary barrier. Your tertiary barrier will be the plug that you put in the tubing hanger, the BPV. Once you set these 3 barriers and test them, then the Christmas tree you can release it, change it. Wellhead and Christmas tree. Now we'll go above ground so we can breathe now. For years, working in the oil field, I'm a mechanical engineer, graduated back in 1983, and all my life I spent with international organization, worked in so many countries. For a period of time, I had this impression that Wellhead and Christmas tree is the same thing. What is this? This is a Wellhead. Can I call it Christmas tree? Of course you can call it. It's the same. Then I discovered that no, they are not the same. They are two different elements. We put the Christmas tree on top of the Wellhead. What is the Wellhead engineering-wise? The Wellhead is the components of tubing hanger, and tubing casing hangers. We have more than casing hanger, we have one tubing hanger. So a Wellhead is the components of casing hangers, casing heads, tubing hanger, tubing head. On top of that, we put the Christmas tree. The Christmas tree is the components of valves that control the flow of the well. The connection between both the wellhead and Christmas tree, we call it THF, stands for tubing head flange. So if we go to this drawing, you see it in front of you now, and here, if I draw a line here, whatever on top of this line is a Christmas tree. Whatever below is the wellhead. And this is, as you see here with the red arrow, it is wireline 0 point, or call tubing 0 point. This is where we take our zero counter. We put zero on the counter, so we start running in the hole regarding with coil tubing with wireline. Most of the time we use the tubing head flange as a reference for depth. The wellhead, the purpose of the wellhead, it is anchor and connection for each individual casing, because when we run a casing, we run more than one casing. Why we run more than one casing? Why don't, Ahmed, when we drill a well, we start with a hole 7-inch, and we need to go to 10,000 feet, so we drill this 10,000 feet, one time, then run one size casing 7-inch all the way. You cannot do that, because if you go to the beach, play with your kids, and you dig with your hand on the sand, when you dig 1 foot or 2 foot, what will happen? The hole will collapse. So what about 10,000 feet? It will not collapse? That's why you have to drill a little bit and then secure your hole. Secure your hole. This is one of the reasons you have this casing, to secure this hole, or sometimes also to prevent unwanted fluids because while drilling you will have different formation that not those are gas cap formation, water formation, not desired. So you have to protect. Then you have to run this casing to protect the part of the hole that you drill. And then when you run again, you have to go to smaller sizes to be able to run through. That's why we have more than one case until we reach the depth. So it is to pressure isolation for individual casing between each casing and the other. We needed to connect the Christmas tree above it. But all these reasons are reasons for why we need a wellhead. Two types of wellhead we have, either compact or conventional. Compact, we'll talk about it, but this is how it looks like if we are drilling a well. You will see that we have more than one casing, that you see this casing with different colors, ends with a liner. Normally, we drill a big hole, we call it conductor pipe. It reaches up to maybe 40-inch diameter. And when we drill this hole, we cannot go deeper. Maximum between 40 to 400 feet, we have to stop, because normally the top ground, the soil on the top, it is unconsolidated. It's very soft, so it will collapse easier. And then we have our conductor pipe. Then we need to continue drilling. Then we have to go smaller sizes, which might go with the surface casing, that we might go all the way maybe up to 2,000 feet and then stop and secure our well. And we have, each case we have to cement. You see, for example, this is the conductor pipe, and then we run the surface casing. And then once we run the surface casing, we have to cement it by pumping cement inside, and then we see to fill this gap between the soil, ground, and the casing till we reach cement on top. So we have to cement it, and we keep going till we reach our depth. This is step by step. Actually, quickly, I'll go quickly. This is the conductor pipe, and then normally it's not cemented. But when we go to the surface casing, if we run surface casing, this is the surface casing, which is in blue color, and then we cement it with gray. This gray is cement all the way to the top. Normally size between 13 3/8 and 20, and up to 2,000 feet. And then we run intermediate casing if we need to run intermediate casing. This intermediate casing, which is yellow, it is smaller in size, so normally between 7 and 13 3/8. And when we cement it, if you notice, we didn't cement it all the way to the top. We have just overlap between and the previous casing, because the rest here is secured by the casing, the surface casing itself. So the cement, just to make overlap, a little overlap. When we go farther, not necessarily that in these wells, each well we have to have surface casing, intermediate casing, production casing liner. It depends on the design. Actually, we have wells that we don't have, we have just one size casing and we don't have production tubing. We run the casing, we perforate it, and then we produce from this well without any production tubing and packer. So it depends, so many designs, depends on the design you select. We said the wellhead, we have two types of wellheads. We have a compact well type and conventional. This is the compact wellhead. As you see, we normally use it subsea, and what you see here, this is the seabed. It is on the seabed. The wellhead, we said it is a component of casing hangers, casing heads, tubing hanger, tubing head. In offshore applications, in the past, we have a big steel structure called platforms. But nowadays, we don't have this. Instead, we avoid that, and we have everything on the seabed. To have this on the seabed, we have this compact type, where all these components, casing hanger, casing head, tubing hanger, tubing head, in one body, small body, short in size. This is to shorten the distance that we avoid the ships while sailing from hitting our Christmas tree and wellheads. It has a big advantage, but nothing is for free. What you are losing here, if any component is damaged, you and me cannot fix it. You have to take it out, kiss it, put it beside the wall. We cannot touch it. The only one can play with it is the manufacturer. But what you are using normally, the conventional head or composite wellhead, which is components connected together with API flanges. So this is step by step. If we have the surface casing head, where inside this surface casing head, we will have the surface casing hanger. The surface casing hanger, which is in orange color, that hangs the surface casing, which is in yellow color. What you are running after that? If you are running production casing, then you have to put on top of that production casing head, where inside it you will have production casing hanger. This is the production casing hanger, again in orange color, which hangs the production casing, which is in green color. If you decide in your design that you're going to run production tubing, then please on top of that you're going to put tubing head. This is the tubing head, where inside it you will put tubing hanger. This is the tubing hanger in orange color, which hangs the production tubing, which is in blue color. Now this is the wellhead. And on top of it here, this is what we call tubing head flange, where you're going to put Christmas tree on top of that. The Christmas tree. Before we go to, let's go directly for the Christmas tree. I will skip this one. This is the Christmas tree. The Christmas tree consists of a group of valves connected to each other with API flanges. Why I keep saying, I'm not saying flanges, but I'm saying API flange. Is there any difference between flange and API flange? Of course there is. A flange is you go to the shop near by your home and ask him to make you a flange, red color, 7-inch OD, and please make me 4 holes. Each hole is 1/4 inch. You design it. But this flange, if you take it somewhere else, no one will recognize it. But the API flange is a standard international flange. When I tell you that I need a flange, 518, 3K, plus. By doing this, I know exactly the material of the flange, the height, the width, the depth, the ID, the OD, the number of holes, each hole, the diameter of each one, the number of stud bolts and nuts, the type of stud bolts and nuts. It's international standard. If we start from the lower valve, we call it LMV, lower master valve. This is the most bottom one, and this is not a normally used valve. And I always say in my lecture, if you are in the field and you see one of the guys is going to close the lower master valve, please hit him on the hand, tell him, don't do that again. This is your last resource. This is if everything in front of you became black, go and do that. But normally, why? Because I always say, this is your Lamborghini. So you guys, I have a Lamborghini. I use it only on weekends. Take it from the garage, pass by my girlfriend, have a little tour, take her back home, take my Lamborghini, put it in the garage, shut the door. I will not see this Lamborghini till next week. But when I go to my work every day, I use a bicycle, or I use my Hyundai 79 model. Why? Because I cannot resist the maintenance, preventive maintenance of my Lamborghini. Spare parts, and very expensive, I cannot. But I can with my bicycle or my Hyundai or my old car, whatever the brand is. I'm just giving you an example to understand that this is your Lamborghini. Don't use it regularly, please, because when you use something frequently, you damage it. If this valve is damaged, you don't have any barrier below it to fix it. That's why we use always LMV, UMV, sorry, upper master valve. The upper master valve is normally a used valve, and remember that some can cut the slick line. Some of these valves can cut the slick line. It is designed to cut. And please remember, because this is one of the questions you will have in the exercises, none of these valves seal around wire. These valves are gate valves. They are knives. So whatever in front of it, either it will cut it or it will be damaged and not be able to cut. The only one which is designed to cut slick line only, not wire line, not E-line, not cold tubing, is the upper master valve. It can cut slick line. None of these valves will seal around wire or will seal around pipe. Then we have what we call FWV, flowing valve. This is the flowing valve. This is to allow flow that coming from the well passing through to the production line. And then we have what we call choke valve. Choke valve on the Christmas tree is to regulate. It is to restrict the flow. You need full flow, half flow, three-quarter flow, two-third flow, no flow. This is to control the flow. And actually, I'm missing a valve between this flowing valve and this choke valve. There should be a valve here. This valve I'm missing. We call it SSV, surface safety valve. Some of you guys in the field, they call it actuator. Yes, whatever. SSV, surface safety valve. On the other side of the Christmas tree, we have kill-wing valve. Not many Christmas trees, they don't have this kill-wing valve, and instead they have a blind flange. The reason for the kill-wing valve is where we connect it to the high pressure connections to the pump. So if in case of emergency, we need to kill the well, we just start the pump and pump will kill fluid through. On top, we have what we call swab valve or crown valve. The reason we call it crown valve because it is on top of the Christmas tree. The swab valve or crown valve, it is mainly for well intervention operation. This is only to allow us to rig up and rig down the wire line and cold tubing or snapping. But please, 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 I said it 3 times, please, please, please. The swab valve has nothing to do with the well flow. It does not control the well flow. What control the well flow is the valves in the line, in the passage of the well flow, which is the lower master valve, the upper master valve, the flowing valve, the SSV, and the choke. The kill-wing valve has nothing to do with the flow, and the swab valve on top has nothing to do with the flow. The wellhead connections has to be API flanges. In the past, we have 2 categories, either thread or flange, but khalas, this is history. Now, all connection on the Christmas tree has to be API flanges. Any flange is described by pressure and size. Like here, this flange is 918, 5,000 psi. What this means, what 958 means, and what 5,000 psi means. In 918, this is the idea of the flange. And the 5,000 psi is the working pressure of the flange. So any API flange is identified by the ID and the working pressure. ID and working pressure. I am done with what information I need to pass to you today. And alhamdulillah, it's almost 55 minutes, so it's not a heavy lecture. Now I need Dr. Ahmed Al-Garhi, who raised this question for you guys. I need you to answer it so I can see your answers. The question says, identify 2 of the advantage of installing a production packer. And I gave you 4 answers. I need you to select 2. Out of these 4, there are only 2 good answers and 2 bad answers. I am waiting your answer to feed the final. Done, guys, or not yet? I still see some of you hesitating. I need to answer, remember? So now, let us see your results. To prevent the produced and treatment fluid from coming in contact with the casing, 34%, to supported tubing weight 2%, to isolate 59%, to anchor the bottom of the tubing is only 5%. I am happy with these results. Let's go for the good answer. What's the good answer? The good answer represents the majority of you guys, which you select. It is to isolate the annulus so that it can be filled with Packer fluid, which protects the casing and production tubing against corrosion and prevents large differential pressure. This is correct. And the majority of you guys selected because it has the word isolate. And we said Packer is to isolate, which is fine. Let's go for the second answer because you didn't see in the second answer the word isolate. But it is there in the word prevent. It is answer number A. It is to prevent the produced and treatment fluid from coming into contact with the casing. Remember, I said that if there is no Packer and you are pumping acid in the production tubing to enter the formation, if there is no Packer, it will not enter the formation. It will go back and making you tubing and goes to the annulus, damaging your casing. But I didn't finish yet. I have to explain why the two answers are wrong, why to support the tubing weight is wrong, why to anchor the bottom of the tubing is wrong, why in Ahmed we said that what hangs in bottom completion, which is the tailpipe, we said the Packer. But I also said that it is not in her job description. And I said that she is doing that as a favor. I am not going out to get cigarettes for Dr. Ahmed. I'm going to buy the milk for me from the supermarket. Remember this example I gave you. So if I have the correct answer, which is isolate or prevent, I should not go for that. That's why to anchor is wrong and to support the tubing weight. Actually, what support the tubing weight, I need to kill this one person who said to support the tubing weight, but support the tubing weight is the tubing hanger. And it supports only the top tubing weight, which is the top completion. Anyhow, I'm happy that the majority of you selected the good answers, which is prevent and isolate. I am done for today. Thank you very much for your patience and listening to me all this one complete hour. I'll see you in a few days when we come to talk about cold tubing, which is my favorite.
Thank you, Engineer Ahmed. Actually, we have a lot of questions, so I'll pick some.
I'm ready.
Of them. Omar asked if the above the Packer is called top assembly and the below Packer is called the bottom assembly. So what we call the between the two Packers?
Between the two Packer is part of the top completion. We consider it as part of the top completion, which is actually a joint or two. It's not much. Sometimes we reach 200 feet different between the bottom and the top completion. The reason we have bottom and top completion because we have more than one dome. But in this middle, we consider it as part of the top completion.
Okay. Ryan asked, does setting Packers mentioned in this lecture apply for inflatable Packer as well? Sorry.
No, I didn't talk about the inflatable Packer in this session. The inflatable Packers, we use it with the well intervention technique. We run it with the wireline, whatever the wireline is E-line or cold tubing. But we didn't talk about that, and they have different techniques of setting.
Okay. So other question asked, do we have production casing in injection wells?
It depends. All these type. It depends on the design. Actually, where you design your well, you design it initially to do it as injection, or it was a production well. And then after a time, you decide to use it as injection. So the scenario of designs is tremendous. Which one you select, depending on having a certain data you collect from this particular location. And based on that, you go to the engineer and he will tell you the best scenario to make your well.
Okay. Other question is said like why BOP is set after service casing?
That we run BOB after surface casing. This is not correct. The BOB, we use it while drilling regarding whatever you run, but BOB is there. You have to have the BOB because it is your blowout control. It is blowout preventer. It prevents. So you have to have it. You cannot drill a well or produce from a well, or you do work over, or you run coil tubing or wireline without BOB. So this is a must.
Okay. Other question, in which situation we don't run production tubing and just we perforate the casing? And when we do?
Look, we have new technology now that instead of drilling a well, we normally drill a well in sometimes in 2 months. Now, the same well that we used to drill it in 2 months, we drill it in 10 days now. In some application, when we know that we have a reservoir that it will not last longer, so actually there is no need to have all these costs of making a complete well with complete accessories and complete production tubing. So what we do is actually we drill a well, not with a drill pipe even, we drill a well with the casing. And once we finish drilling the well with the casing, خلاص, the casing is what we do at the end. We perforate this casing and we produce from it. No need for production tube, no need for accessories, no need for drill pipe even, and drill coolers. But again, it's on the data we select from the well to see the best scenario we use.
All right. Engineer Ahmed, can I ask you how the other audience can reach you? Because one of the questions is really long with the calculation and he wants help with this question, and there are more than 20 or questions.
Dr. Ahmed Al-Garhi has my email address, and no problem for any one of you guys to reach me through the email or through my WhatsApp, which is already again with, or messengers that Dr. Ahmed can provide you with.
Okay, I take all the questions and I'll send you an email and we'll share the answers with them. Okay, Dr. Engineer Ahmed, thank you very much. And I want to mention that next session with Engineer Ahmed will be on 21st of August. Okay, and that's all for today. Thank you all, and thanks, Engineer Ahmed. Bye all.
Thank you very much. See you. Bye. Bye.